All right, ladies and gentlemen. Okay, so we're going to go over Newton's law of universal gravitation. So we've already looked at centripetal force. All right, so you're looking at an object going around in a circle, okay, and calculating its velocity, its acceleration, things like that. What we are now looking at is the universal law of gravitation, and that's looking at when you have two objects involved. So you're looking at specifically what's happening between the interactions of two things. So let's say like you have the Earth going around the sun, or the moon going around the Earth. All right. So you're taking both objects into account. So gravitational force is the force between two objects. It says it must be proportional to the object's mass. The force between the two objects, that is so incorrectly worded. The force between two objects must be, that's why I couldn't figure it out, must be proportional to the object's masses. All right, so it is directly proportional. So what that means is that if your masses of your objects are increasing, what's happening to the force between them? What happens to the force between them? It's going to increase. So you know that as far as if you have one object orbiting another object, what happens is like a small mass is not going to have, there's not going to be as much of a force, gravitational force between them as if the masses are larger, right? So your larger planets are going to have the greater gravitational force, right? Okay. So the equations, law of universal gravitation states that objects attract other objects with a force that is proportional to the product of their masses, multiplied together, and inversely proportional to the square of the distance between them. So it says inversely proportional to the square of the distance between them. So if I'm looking at a distance like this, all right, but then I'm going to do it right here. So if I'm looking at here's one object and here's one object, all right, this is the distance between them. But if this object, let's say it's the moon going around the Earth, and it's going around, that distance now becomes what? What is that distance as far as this distance here becomes the radius of that circle? Okay, so what happens if your radius is or your distance between those objects is increasing? Would you expect more of a gravitational pull or less? Less. All right, so the further you get away from Earth, the less of that pull you're going to feel by its gravity. Okay, so that's what this is saying here. So if the masses are increasing, objects heavier mass, force is going to increase between them. Increase the distance between them, then your force is going to decrease. Okay? So the equation for that is gravitational force is equal to, you have what's called a gravitational constant, universal gravitation constant, which is symbolized with a capital G. And then remember that it is the product force is the product of the two masses. So M1 times M2, inversely proportional to the square of the distance between them, which becomes the radius if it is something is orbiting something else. So you may see this equation written with a D, okay, D squared or an R squared. Distance with D, if it's just there's a distance between them, but it's not actually anything orbiting. Okay, so you may see it written either way. So that means when you're using this equation, your universal gravitation constant is this number. You always plug that in for your capital G. That is a constant. It doesn't matter what object you're talking about, that is going to be your constant. So the number is 6.673 times 10 to the negative 11 newtons times meter squared over kilograms squared. That's all the units. All right. You don't have to memorize this number. It is on your physics reference sheet, so you'll get that for tests. Okay. Any questions on that? Make sure you write down your units. That way, when you are doing the math, you can see what cancels out. All right. That is your check, just to make sure that the problem is set up right. Okay. So we had talked about a little bit before. I think it was last week. We had done a little bit something with proportions. Do you remember saying anything about that? So okay. So what we're going to look at is the relationship between your masses and the force. So we're just going to say F is proportional to M1 times M2. And just as if this was an equal sign, this is directly related. Okay? So force is proportional to the product of your masses. Okay? Sometimes when you're looking at problems, they will give you some questions, and if you're looking at the proportions, you don't actually have to go through and plug in all the numbers to determine what the relationship is. All right? It can be faster just to look at this, how they're related to each other, the relationships between them, all right, to figure out an answer. So this is a direct relationship. If your masses increase, if either one of them increases, it doesn't have to necessarily be both of them. If one of these increases, then your force is going to increase. Okay, so again, direct relationship, one of these goes up, then what happens is your force is going to go up. So let's say I had something like, let's say that what happens is, for example, I double my first mass. So we're talking about there was an original mass, but I'm saying what would happen if you double the mass of one of the objects, so like M1, what would happen to the force? So the way you look at it is we have 2 times your M1 times whatever your M2 is. Well, if I'm multiplying this side by 2, then what happens to this? It's going to be doubled, right? Okay, so you double one of the masses. It doesn't have to be both of them. If I double one of the masses, then the result is my force will be doubled, whatever the original was. Okay, what if I triple the second mass? And the way I do this is I just kind of plug in, okay, so M1 is going to be the same, but I'm going to triple my second mass. What is that going to do? What is that going to do? What is it going to do? It will triple the force, right? Because you're multiplying this side. It doesn't matter where you put it. You're still multiplying the side by 3. Okay, so now remember, I'm not taking your radius into consideration here. We are looking at, this is my independent variable. My force is going to be my dependent variable. All right? So that means radius needs to be held what? Is my radius changing? It's constant. So that's why we're taking it out. It's constant. So if I triple my second mass, I'm still multiplying the top of this thing by 3, so my force will also triple. So I'm going to have 3 times whatever the original force was. What if I do something like double my first mass and I triple my second mass? Good. Okay, so the force will be 6 times greater. 2 times 3 is 6. So there will be some questions like this in your assignment. And then what if I half my first mass and I half my second mass? So originally this was, we'll make it something smaller, 4 kilograms, and this one was 2 kilograms, and I half them both. What happens? This was originally 4, and this one was 2. Okay, so I hear 1/4. So if this was 4 and 2, then my force would have been 8, right? Now it is 2 and 1.
It's 2.
2 times 1.
Oh, it's 2.
Which is how much of 8? 1/4. So this is what, if you forget about the proportional stuff, you can actually plug in the numbers and do it. Okay? So I could plug in the 4 and the 2 and get the 8, and then I can go back, okay, well, half of that, I'm going to plug in the 2 and 1. Well, that's 2, so how much of the 8 is that? You can plug in the numbers, but you really don't have to, because I'm just going to do 1/2 times 1/2.
You made it rough.
Sorry. All right, so you're going to end up with 1/4 of the original force. Okay, so let's take a look at the relationship between your force and your radius. It is proportional to the inverse of the radius squared. So let's see. what happens is, so this is an inverse relationship. Diagonal, numerator, denominator automatically tells you that if one of these goes down, the other one's going to go up. It's not going to be a linear, though. Okay, you're going to be looking at a curve. But this goes up, this went down. If this went up, then this had to go down. All right, so inverse, they're doing the opposite. Okay, so let's say what happens is I double my radius. I double my radius. Force is going to go down, but by how much?
1/2 force.
Is it 1/2?
Yeah, 1 force. You just split the 1 force.
Okay, so plug in that 2 into this right here for the radius. If I double my radius, because it's squared, okay? So your force will be 1/4 of the original. So think of it as plugging that number in for this. 2 squared is 4, so it's 1/4. What about if I triple my radius? 1/9, good. What if I cut my radius in half? Double the force? Is it?
Yes. Yeah, I'm saying it's 1/4 over 1/4, which is the first.
You're cutting the radius in half. So this is, okay, so you have your force is proportional to 1 over r squared, right? And we are cutting our radius in half. That's an r. Plugging that in, this is like 1 over 1/2 squared, which would be 1 over 1/4, which is, so does that mean I'm 1/4 of my force, of the original force? Don't you do like, do y'all remember that? 4.
Yeah.
So your force is going to quadruple.
Yes.
Okay. Did anyone need this? How I worked that out? Did anyone need to write that down?
No.
Okay, so we have, let me make it neater for you. So, let me do like this. You have, this was the original equation. And so we're going to cut radius in half. So as far as the math, you're looking at this equation, you're going to have 1 over 1/2, that number right there, squared. Becomes 1 over 1/2 squared is 1/4. So we have 1 over 1/4. You don't leave a fraction down here. We need to get rid of that fraction. So you multiply by the reciprocal, but you do it to the top and the bottom. All right? So times 4 over 1 here, and on top, you're also going to have times 4 over 1. Bottom here cancels out. Now I have 4 over 1. So it's just, this is 4. So as far as your radius, it is quadrupling. You're going to have 4 times what the original force was, if you have the radius. Any questions on this one? All right. Try this one. Don't say it out loud, though. Try it on paper and see what you come up with. We have 1/3 of the original radius. Don't say it out loud. Work it out. See what you get. It's not on, that's by itself, but you may have
That's by
questions.
itself before the equation.
There's a question. Okay. All right, so You have 1/3 R. F is proportional to 1 over 1/3 squared. What does that come out to be? 1/9, which you're going to flip it. So force is going to be 9 times greater. Okay, so where might you see something like that? Take a look at this problem. This was actually, I don't know if y'all remember when we had like, well, you have CAST now, the state standard, CST, probably don't remember that. But so this was actually one of the questions on the CST. Okay, so it says, what event, what event will produce the greatest increase in the gravitational force? So we're looking for the greatest force. They're not telling you it's 4 times or whatever. We want the greatest force. All right? Which event will produce the greatest increase in the gravitational force between the two masses? So they give you masses, they give you the distance between, and then they start doubling the large mass. So I'm going to double this one. Or I'm going to double my distance. Or I'm going to reduce the small this one by half. I'm going to half my M2. Or I'm going to half this, it becomes 0.25, half the radius in between. So you can, if you want to, go through and plug in all the numbers into that equation, the G equals, the F equals G. Because you're still going to look at proportions. I could do it F equals M1, M2 over R squared and plug in all those numbers. Change the numbers. Oh, they want me to double the large mass. Well, I'm going to plug 250 in here. I'm going to plug 150 in here, and I'm going to use 0.5. You can do that with every single one of them. Okay? So if you're having trouble with the proportions, yes, go through and do the math. Plug in all the numbers into this. Or you can just look at the proportions. All right? So what am I doing with the large mass? I'm doubling it. So you know what I'm going to do? I'm going to do, I doubled it. What am I doing? Is that the only thing I'm doing?
Yes.
Doubling the large mass, and you're not changing anything else. What's that going to do to the force? It's going to do what? Double the force. Okay. Doubling the distance between. All right. So that's all I'm changing is doubling the distance. Now you're back to the 1 over R squared. So if you double the distance between, what happens to the force? You're going to end up with 1/4. Okay. So right now for A we're going to double the force. For B we're going to end up with 1/4 the force. Okay. So you see what's happening here? Rather than me having to do all the math, we're looking at it this way. All right, C, if I reduce the small mass by half. So I'm cutting one of the masses in half. What do I end up with? You're going to half the force. D, reduce the distance between the masses by half. So we have that, right?
Yep, might be 4 times.
And it's going to be 4 times. So which one, the question was, which one's going to create the greater force?
D.
D. Okay?
So cool.
It's a lot faster than plugging in all the numbers. Okay, so just it's up to you. If you have trouble with this, I can sit there and plug in all the. I've done that before. I've sat there and plugged in all the numbers. All right, but this is a lot faster if you're looking at the proportion. All right, so just. Will you have a question like that? Yes.
The science portion of the CST was also math.
Hmm.
The science portion of CST was math portion also, right?
Well, it's physics. Algebra-based concept. Yes, look at all these problems.
Algebra.
This is algebra. This isn't calculus. Yes. All right. Okay. All right. So now let's take this and apply it to problems use that equation to apply to problems. Determine the force of gravitational. These are basically these two. These two are proportion questions, kind of like what you've been doing, and these are actually just using that equation here. So it says determine the force of gravitational attraction between the Earth. So we're looking for the force of gravitation, Fg, between the Earth. Earth has a mass of 5.98 times 10 to the 24th kilograms, and a 70 kilogram physics student. Okay, so I have an M1, which is 5.98 times 10 to the 24th kilograms. And then we also have the mass of your student on Earth, 70 kilograms. If the student is standing at sea level, a distance of, so what is that? Distance of 6.38 times 10 to the 6 meters from the Earth's center. That's going to be your radius. Now these problems, I don't think they're difficult. I think they're pretty straightforward, but be careful with your calculations. Be careful plugging stuff into your calculator. Okay, that's where a lot of the mistakes happen. So go back and check, double check, make sure everything's entered correctly. Okay? Lots of numbers, lots of exponents, lots of places to make mistakes. So your equation is, now we're going to go back and look at the equation at the top. Look at that equation. Fg equals G.
So you can find G now.
Nope, you don't need to find G. Capital G? Universal gravitation constant? That number right here. Every time. Yes. So what we are looking for is force. We're solving for this. So all you have to do is plug in your numbers. We have F, your force is mass 1. Oh, I forgot to write down. G, get your G. G is 6.673 times 10 to the negative 11 newtons times meters squared over kilograms squared. Yes. That's my G. What equation are you using? It's G. Okay, times my mass 1. .98 times 10 to the 24th kilograms. Make sure your units are in kilograms. You're using newtons, you're using meters, you're using kilograms. Times 70 kilograms. And then you're going to divide that by your radius squared. 6.38 times 10 to the meters. Make sure you square your radius. Make sure to square your radius. I didn't leave any place for my answer. I'll show you. You all ready? Yes. I'm sorry? I think it looks like a notebook. I don't know what it does. I suppose you're supposed to read the manuals that come with. I don't do that until I break it.
Something you have to read.
But I have to read it. How to fix it. I learned something really cool about cars. I've been driving for years. You know, on your dash they have that little image of like a gas tank. Yeah. There's an arrow.
What side it's on?
Yes, I never knew that. That's cool. I was always getting out and pull up and then, oh, wrong side, turn around. But I'm told it says that in the manual if you actually look.
I didn't know that.
Yeah,
That works.
well, if you rent cars and things like that, unless I don't usually check until I actually need gas. Now I know without getting out of my car. It's great.
I'm gonna look at that today.
All right, so I'll come up with a, here, ready for me to show you? You got it written down? Okay, so I'm going to put this up here. Let's see. Okay, so what I do is I just run everything on top, run it together, put it in one set of parentheses. So 6.673. Everyone knows how to get exponents on their calculator? All right. No? Okay, so 6.673. When you see the times 10, this part right here, do not, I repeat, do not hit the multiplication sign. Do not use the multiplication sign on your calculator. Times 10 is your exponent. Look for a key. If you're using the TIs for this class, there is a button that says, I don't know if it's the X to negative 1, up in your function keys right here. It's up in the top, like bottom left. And there's like a little blue E above it. Does everyone see that on the TIs? So you need to use the second key to get to that. So what you're going to do is you're going to hit 6.673 second, and then that little E. Okay? So you should have an E that pops up on your calculator. You can try that. I don't know. Sometimes that doesn't. Okay, I don't know if students are doing it differently. It may work or not. You can try it. So 6.673 E, and then with your negative, do not hit the minus sign. You're looking for the negative that's in parentheses. The negative that's in parentheses. All right. So I have 6. Now, if you're using the Casios, down at the bottom you have an EXP button. That's an exponent button. If you're using the Casios, it's the exponent button on the bottom. So 6.673 EXP, exponent, negative 23. Use the negative that's in parentheses.
I just use the multiplication sign.
There's probably different ways to do it. If you know how to use it, yeah, mine just says times 10 to the X. So times 10 to the, because this is my Casio.
How much did that cost?
I don't know.
Like $20?
Probably about a little bit more, maybe. Okay, so 6.673. Oh, I'm sorry. Parentheses 6.673 times 10 to the negative 11 times 5.98, again, exponent to the 24th, times 70, close parentheses. Tells your calculator all this stuff needs to go together. Multiply all this stuff together first. So it multiplies all that together, and then I say divide by, and then I put the stuff on the bottom. So 6.38 exponent 6, and then I just hit squared equals. Answer is 686.24. I do it wrong. 686.24. Check what cancels out. I got kilograms times kilograms, which would be kilograms squared, but it's divided by kilograms squared, so those cancel out. I have meters squared here, meters here, that cancels out, and you're left with newtons, which you should have because you are calculating a force. Okay, so after you get that one written down, go ahead and try the next one. Okay, now, there is no try, do.
Wait, this one doesn't have radius.
Who said that?
Yoda.
Yeah.
Yoda.
There is no try.
Little Star Wars dude? Yeah, you can try.
Have you seen that picture? They put it in the
So do number 2.
Just do it.
Just do it.
It's kind of funny though.
That's another slogan. Just do it. Slogan day. Just do it. calculator?
Oh, here he is from the first century. Is that a lot of force right there? 680? Like, does that mean, like, I don't know. It's
As compared to what kind of force are you? Wrong.
We were talking about when you were doing like find the test. Yeah, that thing. Find cow. He was talking about that. So I want to do practices. That's what I thought. You should do practices.
He's like, I separated this one. Sure, you should 14 minutes.
That's really weird.
Okay, all right.
I know you don't practice and just do the test. It's weird. It's weird. I won't let it happen.
You need to put in your
I like to do it.
just go ahead and
You guys know the calculator's come with free snacks in the back? What? Yeah, really. Hey, Bo, did your calculator come with free snacks in the back?
You know what mine does?
Yeah, we got free snacks.
Yeah, you know what mine comes with? Hold up.
He puts the wrong face.
Anybody else need help with calculators? Okay. All right, let's look at the next one. I'll do. Okay, so I'm going to help you with number 3. Your own. These have to do with the relationships, looking at proportions. Number 3 says, suppose that two objects attract each other with a gravitational force of 16 Newton. If the distance, so this is Newton's over here, so 16 units. If the distance between the two objects is doubled, so what am I doing? What am I changing? Your radius, okay? What is the new force of attraction between the two objects? So we know that this is the original. You can think of it F sub O, right? F is proportional to 1 over, you said you are doubling the radius. So 2 squared means what are you doing to the force then? 1/4. Okay, so this is going to be 1/4 of whatever the original is. Plug in your numbers. We need an actual answer here. 1/4 of 16 units is 4 units. Yes. And that's it. So you are still doing it the way that we did it up top with the proportions. But then once you get what should happen to it, plug in the original number and get a final answer. Okay, so go ahead and do number 4. Okay, so this one says, suppose that two objects attract each other with a gravitational force of 16 units. If the distance between the two objects is reduced in half, then what is the new force of attraction? So, what do I write here? Good. 1 over 1/2 squared, which would be what? 1 over 1/4, which is actually 4. 4 times the original. Good. That's it. Okay. So otherwise, you just have the 2 worksheets that I gave you to work on. You have 4. Your additional practice is 4 problems. It just has to do with this, and then your other one is a mixture of this plus your circular motion. All right. Any questions?